So, as part of our technical learning is concerned, today we are discussing about BigQuery because BigQuery is one of the serverless as well as high scalable multi-cloud data warehousing application, uh, wherein in regard to the particular technical white paper I'm explaining here. So, this details about the technical architecture, which majorly allows technical BigQueries to perform any petadata byte scale analysis, right? So that when there is any traditional database management system we are using, we must understand how these multi-cloud data warehousing systems or applications are really useful. In that regard, so first one, we must be knowing about the serverless architecture, right? So serverless architecture is majorly in BigQuery, which majorly manages, right? So let's say Google means manages all the underlying infrastructures, including any resource provisioning, scaling, all these. Majorly, this is allow users to focus exclusive on the data analysis using any kind of standard SQL query languages we are using. So SQL, we know, like to extract any queries from the database, SQL queries can be written. So this is exclusively for data analysis using for standard SQL query, we will be using this. So hence this serverless architecture has data storage. What are the different leverages of Colossus we have? At the same time, whatever the distributed system that we are developing. So when there is any kind of data storage in any proprietary column or formats that we are managing, which is also called as capacitors. So which can be divided into two parts. One is about columnar efficiency, second about the durability. Columnar efficiency, only the columns required for any query, which are being scanned, drastically reducing any input and output streaming, increasing the speed, etc. Durability is something where data automatically replicate across multiple availability zones within the specific region. So these are all will be a part of data storage. Next, when it comes to the query execution is concerned, Dremel, which is one of the query execution engine we use it, which turns the SQL queries into execution trees. Whenever there is any kind of slots that we want to perform for any actual data processing, we will be doing for either for dynamic scheduling or at the same time parallelism. Dynamic scheduling, whatever the slots that we are allocating, right? So dynamically across thousands of nodes based on the query complexity, this dynamic scheduling is being used. At the same time, parallelism is a single query which can be utilized somewhere around thousands of slots simultaneously, so that scanning the petabytes of data in seconds, everything can be done under the query execution. Next, we can use high-speed networking, which is using for Jupyter, because if you want to move the data between storage and as well as compute with a lightning speed, okay. So BigQuery is being used Jupyter for this network, so which majorly provides a sufficient bandwidth, allowing workers to read the data, at the same time speed of local disk, and effectively eliminating the network bottlenecks. Everything can be done under the high-speed networking of Jupyter. Next one about integrated intelligence, because BigQuery is more than as it's a warehouse. It's a kind of platform for intelligence with any BigQuery ML, so that users can build machine learning models using standard SQL. So everything can be done using the integrated intelligence approach. So these are the major technical understanding or technical specification when it comes to the Google BigQuery is concerned, right? So when we are learning or when we're trying to understand about this technicality, this technical white paper is majorly details all this.